Hey guys, this is a video on section 12.4, the cross product. The cross product is actually a vector, u cross v. We say u cross v, and it looks like u times v, and that's this red vector here. And u cross v is gotten from u and v by taking the determinant of a matrix. But visually, as you can see here, u cross v is perpendicular or at a right angle to both vector v and vector u. So those are both right angles. And since it's perpendicular to both of those vectors, it actually is perpendicular to the plane formed by u and v. Okay, so the cross product of u and v, of vector u and vector v, is written u cross v, okay, and it's perpendicular to the plane formed by u and v. So that's this horizontal plane here formed by u and v. And remember, perpendicular means it's at a right angle to that plane. Okay, so 90-degree angle. Okay, so the cross product is perpendicular to the plane formed by u and v. And if you think about it, this drawing that I've drawn here, the red vector, it is perpendicular to both u and v, but you might be wondering, well, how come it's pointing this way and not pointing down? Because if it were pointing down, it would still be perpendicular to the plane. And the answer is you can use what's called the right-hand rule to decide which direction u cross v goes. Okay? So the right-hand rule says that for u cross v, you put your right hand with your fingers on u, and then you curl your fingers towards v, and then whichever direction your thumb is pointing, that tells you the direction of u cross v. And that's something that you'll learn more about in physics. We don't really need that so much here, but that's the right-hand rule. I'm not going to write that down because you aren't going to need it for your homework. But yeah, the way you know which way it goes is you start at u with your fingers of your right hand, then you curl your fingers towards v, and then whichever direction your thumb is pointing, that's the direction of u cross v. Okay, but for us, we're going to be focusing more on the math. In fact, we're not going to see any graphs to speak of in our homework. Okay, so how do you find u cross v, and what's the math behind it? The math is a little bit complicated, but if you've done determinants before, you'll find it pretty easy. So u cross v is actually given by the determinant of a matrix. And if you don't know what that means, that's fine. We'll be talking about it in detail here. But it's actually the determinant of the matrix, and it's a 3 by 3 matrix, which means it has 3 rows and 3 columns. The first row is I, j, and k. Those are the unit vectors in the x, y, and z direction. And then your last 2 rows of the matrix are going to be the coordinates of your vectors. So if vector u is given by u1, u2, u3, then the second row of our matrix is going to be u1, u2, u3. Okay? And then same thing with v. If v is given by v1, v2, v3, our third row here is going to be V1, V2, V3. Okay, and this vertical, these vertical lines actually mean determinant. This is a determinant. Okay, and so this is the determinant of a matrix. Determinant of a matrix. And if you've done determinants before, you're going to find this to be a lot easier. But even if you haven't done determinants before, it's not too bad once you get used to it. Okay, but I think the best way to teach it is by example. Okay, and remember, I, j, k, those are the unit vectors. u1, u2, u3, those are going to be the coordinates of u. So vector u. Okay, so where vector u equals u1, u2, u3, and vector v equals v1, v2, and v3. And if it looks kind of mysterious, the whole determinant thing, don't worry, we're going to do an example right away. Okay. So, let's do an example. Example. Find u cross v. Find u cross v where vector u equals 3i minus 4j minus k. Okay? And vector v equals I minus k. Okay, so we want to find u cross v where u equals 3i minus 4j minus k, and vector v equals I minus k. Now what you want to do first is you want to write it in the component form as a position vector. Okay, so for vector u, we're going to rewrite this as angle bracket and then 3 comma negative 4 comma negative 1. So that's actually going to be our u1, our u2, and our u3. Okay, and then we also want to do that with vector v. Okay, so vector v, writing it in component form, we can see that I is 1, and then because there's no j, that means the second component is 0. And then we have negative k, so that's going to give us negative 1. Okay, so vector v is going to be 1, comma 0, comma negative 1. So that's v1, v2, v3. Okay, and we want to find u cross v. And we're just going to learn this by example. That's probably the easiest way. Okay, so u cross v is using the formula up here. We write down the matrix, and it's always going to look like this. So the first row is always going to be I, j, k. So we do that first. Let me give myself a little bit more room here. So u cross v here is going to be the determinant of the matrix. The first row is I, j, k. Okay? And then our second row is actually going to be u1, u2, u3. So here that's going to be 3, negative 4, negative 1. Okay, and then my last row is going to be our v1, v2, v3. So that's going to be 1, 0, negative 1. 1, 0, negative 1. So how do you take the determinant? We have it all set up. The basic idea for the determinant is you need to actually split it up into parts. So the way it works is you start with the top left entry, so you start with I. Okay. So to find the determinant, we start with vector I, and we cross out everything in that row and in that column, and then we multiply I times the determinant of this little 2x2 matrix right here. Okay? So what's that going to look like? Well, we're actually going to get vector I times the determinant of what's left. So I cross out everything in the row and column of I, and then I'm taking the determinant of a smaller matrix here. So that's negative 4, negative 1, 0, negative 1. Okay, that's the determinant, but that's just the beginning of it. So you have to do this all the way across this row. Okay, and the name of this little smaller matrix that we have here, this is called a minor. And then these numbers up here are usually called cofactors. Okay, so you basically take the determinant of a minor and you multiply it by each cofactor. So the first thing we have here is I hat times the determinant of this little matrix here. And then the next thing we're going to have is we're going to move on to j hat. Okay, so I'm going to go ahead and erase this. Actually, let me just rewrite it. It's probably faster. Okay, so now we're going to move on to j hat, and it turns out that I hat is going to be positive, but then you need to switch signs when you go to j hat. Okay, so now that we're going to j hat, we're actually going to have minus j hat. Okay, minus j hat, but then we're going to do the same thing we did with I hat, in that we're going to actually cross out that row and that column. Okay, so if I cross out that row and that column that j is in, now we're going to go ahead and multiply this times the determinant of whatever I didn't cross out. So the stuff that I didn't cross out is going to be the matrix 3, negative 1, 1, negative 1. Okay, so that's going to be right here. So we're going to have 3, negative 1, 1, negative 1. Okay, and you might be wondering, well, how do we get a negative j hat here? Well, the way it works is the signs actually alternate for your cofactors. Okay, so you start with positive, and then you go to negative, and then you go to positive. And you're working your way from left to right. And if you've taken linear algebra before, this is all going to be pretty easy for you. But if you haven't, it's new, but you get used to it after a while. It's not actually that hard, it's just a matter of getting used to it. So, so we're actually not quite done with the determinant. So we did I hat times this part minus j hat times this part, and now we're going to do the same thing for k hat. So we're going to have, so let me go over here on the board. We're going to have plus k hat. So the signs actually alternate. So notice we started with positive I hat, and then we did negative j hat, and now we're doing plus k hat. So it starts plus, and then it goes minus, and then it goes plus again. And then we're going to be doing the same process that we did for I hat and j hat, but now we're going to be doing it for k hat. Okay, so let me erase there. Okay, so we had negative 4 and 0 there. And then, so now we're going to be on the k hat for our row and our column, but we're still going to be doing the same stuff. So we're actually going to, that's hard to read. So we're actually going to be, again, crossing out the row and the column that k hat is in. Okay, so we should probably be doing that in red. So crossing out the row and the column that k hat is in, we're going to have plus k hat times whatever I didn't cross out. So what didn't I cross out? I didn't cross out this little matrix here, 3, negative 4, 1, 0. Okay, so we're going to have plus k hat times the determinant of 3, negative 4, 1, 0. Okay, and there are other ways of doing determinants, but this is the way most people do them if you want to do them by hand. There's also determinant calculators online, so you might be able to find one that'll do the determinant for you. But most determinant calculators actually have all numbers. They don't have vectors there. Okay, so that might be tricky to find a calculator that'll do that. Okay, but this right here is actually going to be the whole determinant. Now the only problem is now we have to take the determinant of these three matrices. Okay, we need to take the determinant of each of these. So those are all also determinants. And by the way, if you haven't taken linear algebra before, these matrices here are called 2x2s because they have 2 rows and 2 columns. The original matrix we started with had 3 rows and 3 columns, so this was called a 3x3. So we actually started with a 3x3 matrix, a 3x3 matrix, because it had 3 rows and 3 columns. And we took the determinant of the 3x3, which basically means we broke it up into 3 different determinants of 2x2s. Each of these are 2x2 matrices. Okay, so these are determinants of 2x2 matrices. And matrices is the plural of matrix. Okay? And then how do you take the determinant of a 2x2? That's the big thing that we haven't talked about yet. Well, it turns out there's actually a nice formula for it. So let me write down the determinant. Let me write down the determinant formula. So formula for determinant, formula for determinant of a 2x2. So the determinant of A, B, C, D, where A, B, C, and D are going to be numbers, that's a 2x2 matrix. It turns out that the determinant of a 2x2 is given by the formula AD minus BC. Okay? So the determinant of each of these 2x2 matrices we can determine by just using this formula. All right? So really all that happened here so far is you've got I, J, and K, the signs alternated for those. It starts at plus, minus, plus, and then you have that times the determinants of each minor. And they're called minors because they're 2x2s that are part of the matrix when you delete that row and that column for the I, J, and the K. Okay, and now we're going to go ahead and be doing each of these individual determinants of the 2x2s using this formula. Okay, so let's go ahead and go back up here and write all of this out. Okay, so what we have here is I times the determinant of negative 4, negative 1, that's our AD, minus 0 times negative 1, that's our BC. And if you want, I can even label it just for this one. So here's our A, B, C, D. Okay, so we use the formula AD, which is going to be negative 4 times negative 1. Negative 4 times negative 1 minus BC. So that's going to be minus negative 1 times 0. Okay? And that right there is just using our new formula, AD minus BC. That's the formula for a determinant of a 2 by 2. Okay? And then let's go ahead and do this second determinant. So this one we have minus j hat. Okay, so we have minus j hat. And then we want to use the determinant formula again. I'm using brackets because when you're doing the determinant, it has more than one term. So I need to have a grouping symbol. Okay, so we're going to have minus j hat times AD. So that's going to be 3 times negative 1. 3 times negative 1 minus BC. So that's going to be minus negative 1 times positive 1. So minus negative 1 times positive 1. Okay, so that right there in brackets, that's going to be our second determinant. And again, where are these coming from? These are just using the 2 by 2 determinant formula. So this is AD minus BC. Okay, so now we just have to do it for the last one, for K. So we have positive K times the determinant of this matrix here. So let me go ahead and write that. So our last term is going to be positive K times AD minus BC. So that's going to be 3 times 0 minus 1 times negative 4. Okay, so 3 times 0 minus 1 times negative 4. All right, AD minus BC. All right, and after you do all that, you can go ahead and calculate each of these. So simplifying, our first determinant here is going to be I times, well, I can cross out some of these minuses. Those two minuses cancel out, those two minuses cancel out, and this is a 0. Okay, so for our first determinant, we actually just have 4i. Okay, so we have 4i. And then for our second determinant, these two minuses cancel out and become a plus. So we get negative 3 plus 1, which is negative 2. So we have minus negative 2j for the second component, right? Because this is going to be a negative 3 plus 1, which is negative 2, but there's a minus out front because the signs alternate for your cofactors, for your I, your j, and your k. You always put a minus in front of the second one. Okay, and then for the last component, for k, we actually have 3 times 0 is 0, and then these minuses cancel and we get positive 4. So we have 0 plus 4, so we're actually going to have 4k as our third component. Okay, so we're going to have 4k as our third component. And for our second component, as we all know, 2 minuses makes a plus. So instead of writing minus negative 2j, I'm going to go ahead and cross those out. And that's going to give us positive 2j. So we're going to have 4i plus 2j plus 4k. And that's actually our answer. That is U cross V. Okay? And, you know, I know that's a lot of work, but, you know, after you get practice with it, it's not too bad. It's just if you've never done linear algebra before, it's a bit of a learning curve. But once you get used to it, don't forget that you have my math lab to kind of guide you through each example. So you can do that to supplement my lecture. But hopefully it's not too bad. Alright, and then I also wanted to do another part of this, because when you're doing your homework, they're actually going to ask you to find the length and the direction of u cross v. Okay, so they don't just want you to find u cross v. We just found u cross v. That's a vector that's perpendicular to the plane of u and v. But we actually want to, they actually are going to ask you to find the length and direction, find the length and direction of u cross v. That'll be part of your homework instructions. But since we've already calculated u cross v here, we know that it's 4, 2, 4. Hopefully the length and the direction won't be too hard to calculate. So let's go ahead and start with the length. Remember that the length of a vector is written as, it looks like an absolute value. You have vertical lines on each side. So it looks a lot like the determinant of a matrix, which also has vertical lines. Okay, but since we already know what u cross v is here, we're just going to be taking the length of 4, 2, 4. Okay, so we want to take the length of the vector 4, 2, 4. And remember, when you're finding the length, it's basically just the distance formula. So it's going to be the square root of the sum of the squares. Okay, so here, it's just going to be the square root of each of these squared added together. So it's going to be 4 squared plus 2 squared plus 4 squared. Okay? And then simplifying that, we know that 4 squared is 16, 2 squared is 4, and then this 4 squared is also 16. So we have 16 plus 4 is 20, plus 16 is 36. So for this problem, we actually have the square root of 36, which everyone should know is 6. So the length of u cross v is actually just going to be 6 in this example. Now sometimes you'll have a square root, but we got lucky. This time we don't have a square root, because everything's simplified. Okay, so the length is 6. And remember, the length is the same as the distance from the initial point to the terminal point of the vector. Okay, and then how do we find the direction? Remember that the direction is the same as the vector divided by its length. Okay, so direction is going to be the same as the vector u cross v divided by its length. Okay, so it's going to be u cross v divided by the length of u cross v, which looks kind of complicated when you write it out like this, but we already calculated what u cross v is. So we know that u cross v is going to be 4, 2, 4. So we can write that in for the numerator. 4, 2, 4. And then in the denominator, we just calculated the length. We already know that the length is 6, because we just calculated that. So we're just going to be dividing everything by 6. Okay, so we basically just distribute the 6 to each denominator. So what's that going to give us? Well, we're going to have 4 over 6. For our vector, we're going to have 4 over 6, comma, 2 over 6, comma, 4 over 6. And then in lowest terms, we can divide each of these on the top and the bottom by 2. So we're going to get 4 divided by 2 is 2 over 3. And then we're going to have 1 over 3, and then 2 over 3 again. Just writing those fractions in lowest terms. Okay? So 2/3, comma 1/3, comma 2/3 is actually going to be our answer for the direction. Okay, and I think they want you to write this as ijk. So they want you to write it in terms of unit vectors. So how would we write that? Well, we would write it just in the right order. So it's 2/3 I plus 1/3 j plus 2/3 k. Okay? 2/3 I plus 1/3 j plus 2/3 k. And in your homework, they're also going to be asking you to calculate v cross u. I don't want to go through the whole problem because it'll take a little while, but I will tell you how to set it up. So in your homework, they ask for v cross u. So you have u cross v, which we just did, and then v cross u, keep in mind that's going to be exactly what we just did. It's just we're going to have, the order is switched for v and u. So that's going to still be the determinant of the 3 by 3 I, j, k. But the first vector is v, so it's going to be v1, comma v2, comma v3 for your second row. And then for your third row, you're going to have u1, comma u2, comma u3. Well, I shouldn't be saying comma. So your third row is going to be u1, u2, u3. Okay, but notice that's exactly the same thing we just did. It's just you're going to be putting your vector v for your second row and your vector u for your third row. So it's left to right, top to bottom. Okay, but I don't really want to spend time actually doing that because it's pretty straightforward. It's just what we just did, but just switching the vectors around. Okay, so that is good.